Alright, I'm here at 154 Skyline. There was a house fire here on October 31st that started with a dryer, and what I have here is the dryer cord that we can see here is damaged for sure. It's you can see the conductor, or not the conductor, but the insulation is melted off pretty severely here. What I'm going to do here is a insulation resistance test with the meter we see here, and what it will do is tell me if the insulation has been damaged or compromised, but it has its limits as far as what we can do here. This is basically the only test you're going to be able to do with this to determine the conductor, whether it's still usable or not. So what I'm going to do is go from here to here and check across these, from here to here, here. Basically check. What we shouldn't have is continuity between this wire and any of the other two, or this one and these two here, here and here, or this one and these two. There shouldn't be any connection. If there is, that means the cable's bad. So what I'm going to do here is connect the red wire to one of these here. You can see here in the meter what our reading is. This is a 1,000-volt test also, which will tell us for sure if there's a problem. If you will see here, maybe, I don't know if it'll show up in the video, but there'll be a little spark when I touch these together. I don't know if that shows up. And our numbers go to 0, which means the cable would be bad if it reads 0. What we see right now is 2.2 giga ohms, which means there's no connection between these. So what I'm going to do here on this first one is I'll clip it to that lead there. I'll hit my start, and you can see this wire here that I'm connected to is this prong on this side here, because it goes to 0 on the meter. Now the other two, this is the ground, which is staying at 2.2, which it should, and this one here also stayed at 2.2, which it should. That means this is good. Now I'm going to do the next one, which is the ground on the cord. So it should read 0 when I touch the ground pin on the cord, and it does, which it should. That's right. Here's the other conductor, phase A. Here's the other conductor, phase B. Reads like it should if this was a new cord out of the box. And then we'll do the same test on this here, on this conductor. So this one should read 0 here. When I touch it on there, it's 0. We should not have continuity here. We don't. We shouldn't have continuity here, which we don't. So what this done essentially is, if this was buried in the wall, we wouldn't be able to see. All we could see was each end of this sticking out of the wall. We would determine this is a good cord or a good cable in the wall. But with our eyes, we can see that it is not a good cable. The insulation resistance test I just performed said the insulation is good. But like I'm saying, with the eyes, we can see this insulation is not good. This is the only test you're going to be able to do with a piece of equipment. This is a $1,500 tool to be able to do this test with it. So this is an expensive tool. It's a good tool. We use them all the time in the electrical field, but this is the best you're going to get to be able to do a test on this thing. Other than that, there's no other test to do with this to prove or disprove anything. This is as good as you're going to get. And that's what I'm saying is, if this was in the wall and you used a meter, you're going to determine there's nothing wrong with the cable, even though we know that there definitely is something wrong with this cable.